Hi guys, so today we're going to be talking about key features of graphs. We're going to find things like intercepts, intervals of increase and decrease, maximum and minimum, domain and range. Okay, so let's get started. So the first key feature we're going to talk about is our x-intercept. Okay, so an x-intercept is the point where the graph intersects the x-axis. Right, so for example, this is the x-axis. The x-intercept would be this point here and this point here, right? Because that's where it touches the x-axis. Okay. The other intercept that we care about is the y-intercept. Okay, and that is where the point where the graph intersects the y-axis. Okay, so here is my y-axis. The y-intercept would be right here. Okay. So you should be pretty familiar with that. The next thing is increasing and decreasing behavior. That is new to us. And so what we're always going to do is read the graph from left to right. Okay? It is increasing when y values go upwards. Okay? So as you're tracing it, whenever you feel your finger, so I always have students trace it with their finger. Whenever you feel your finger going upward, that is increasing. Okay? It is decreasing when your y values go downward. So as you're tracing, whenever you trace it downwards, that is decreasing. And it is constant when you see it kind of flatlining like this. That is when it's constant when y values don't change. Right? So here, what we see is that it is increasing when it goes upward. Okay? So tracing it, at this point of the graph, it's going upward. At this point of the graph, it's going upward as well, right? So you're reading it from left to right. Okay, so whenever you go upwards, that is increasing. Okay, it is decreasing whenever you feel it going downward. So for example, if I was tracing it at this point, my finger would be going downwards. That is decreasing. Okay, and then it is constant when it doesn't change. All right, so whenever you feel it going flat, like here. Okay. So this is new to us, right? So the behavior describes what is happening to the y value, and where it occurs are portions of our x values. Okay. And then the last part here is our extrema. Okay, it's where the graph has relatively high or low points. Okay. So we have a relative maximum, right, when there's no other point around it that is higher, right? So I think of it as top of a hill, right? So here, for an example, we have a relative maximum. This is the top of a hill or a mountain, right? Right? Or we see it here. This is like a top of a hill, right? It is a relative minimum when it's the lowest point, right? So here we think of it as the bottom of a valley. So here's like a valley. This is an example of a relative minimum. Okay, so note again, the y value of that point is the value of the min or the max itself. The x value is where the minimum or maximum occurs, right? Just a side comment, we also have something called an absolute max or minimum, but it's a concept that we don't cover in Algebra 1. Okay. The last thing we do is domain, and when we do domain, it is the set of all inputs. It is all of the x values that are on the graph. Okay, and what I want you to think of whenever we think of domain or x, I want you to think in terms of left and right. How far left does the graph go? How far right does the graph go? And then range, I want you to think of it as all outputs, all of our y values on the graph. And we think of it in terms of up and down whenever we think of y. Right? So let's get started actually identifying these points. So the first thing we're going to do is find our x and y intercept. Okay, so here, our x-intercept. Okay, here's our x-axis. Where does it touch our x-axis? It touches our x-axis here and here. Right? And so this point here, the ordered pair is negative 40, 0. This point here is 20, 0. Okay, and so that's the x-intercept. The y-intercept is where it crosses our y-axis. So here's our y-axis, and our graph crosses it right here. Right? This point, the ordered pair, is 0, 20. Okay. So let's try the next one. Okay, so x-intercept is where it crosses the x-axis. So here's the x-axis. As you see, my graph doesn't touch it at all, so there is no x-intercept. So you can either write none or NA, not applicable. Okay. The y-intercept is where it crosses the y-axis, and it does so right here. And I know you can't really see the numbers, but it's 2, 4, 6, that's 8. So between 6 and 8, that is 7. So my y-intercept here is 0, 7. Okay, so I'm going to have you try this next one. Find the x-intercept and the y-intercept. So this is what you should have gotten. X-intercept is -5, 0, -1, 0, and 2, 0. And the y-intercept where it crosses the y-axis is here at 0, -10. Okay. So next, let's talk about increasing and decreasing behavior. So what we do is we go from left to right. We trace it with our finger. Anytime it goes up, that is increasing. Anytime it goes down is decreasing. Okay, so starting here, from here to here, I feel my finger going up. So that is where it is increasing. And what we do is we look at the x values. Okay, so here, from here to here, our y values increase, but we want to talk about where it's happening. Okay, so it is happening from my x values from -4 to -2. Right, so between -4 to -2 for my x values, my y values here are increasing. They are going up. Okay? Then I'm going to keep tracing it. Now here, I feel my finger going down. That is meaning they are decreasing. Okay? And so the y values are going down. We want to know where it happens. So we're just going to look at the x values here. Okay? And so it is decreasing from the x values between -2 and 3. Okay, this is where it is decreasing. Okay. Then, as I continue tracing it, I feel my finger going up again. Okay, so I have another interval where it's increasing. That is between 3 to 4. Okay. So between my x values between 3 to 4, that's when my y goes up. Okay. Right. When we have multiple intervals like that, we combine it with the letter U for union, meaning it is increasing here and it is increasing here. Okay. Then after that, the next part here, my finger is going flat. Okay, so this is constant. So that, I want just the x values of where it is happening. So that is happening for all of my x values between 4 and 5. Okay. Then after that, I feel my finger going up again. So here, this is from 5 to 6. Okay. So 5, between 5 and 6, I am increasing again. Right? So what we're doing here is we're seeing where is our y values going up and down, and we want to know the where, which is the x values. Okay, so the y is the behavior, increasing, decreasing, constant, is talking about where our y values go up and down, and then we want where it's happening. Okay, so let's try another one here. Okay. So always read it from left to right. So here, I feel it going upwards. Right, so here it is increasing. Right. So here is -10, 30. Right? But really, all I care is about where it's happening. Okay, so here it's starting from this arrow, meaning it goes on forever this way, all the way up to -10. So it is increasing whenever the x values are less than -10, right? Because all of these x values are smaller than -10, right? Then decreasing. So here is increasing. Now, once I go on this part of the graph, I feel my finger going down. This is where it's decreasing. And all of these x values, right, so here's the negative 10 one, all of these x values are now going up, so it is decreasing where it is greater than negative 10. Okay. Constant is where it flatlines. It doesn't flatline at all, so that is not applicable, or there is no interval where it is constant. Okay, so let's try another one. Okay, so again, I trace from left to right. So here, I'm tracing, I'm going down. Okay, so this is decreasing. Right? This point here is 2, 3, but again, all I'm looking at really is that x value. Right? Same thing with here. I was just looking at the x value of where it's happening. Right? So same thing, I'm just looking here. So it is decreasing from all my small numbers up till 2. So it is decreasing wherever x is less than that 2. Okay. Then afterwards, continuing to trace, now I'm going upwards. That means I am increasing here. Okay. And so here, all these x values are now going to be bigger than 2, right? So like this one is 3, 7, right, etc. So it is increasing whenever x is greater than 2. Okay. Constant, does it flatline? It does not, so not applicable. Okay. So here's the next part. So first I'm going to color, we are going to go left to right. So here, I'm increasing. Okay. Then when I continue tracing, now I'm decreasing. Here. And then as I continue tracing, here I'm going up again. That's increasing. Okay. So we want to know where it happens. So this here is like negative 3.5 comma like maybe 21 or something. Okay, here to here, this is like 0.5 comma maybe like negative 12 or something, right? But all I care about is where it's happening, and the where it's happening is the x. Okay. So it is increasing, right? Whenever it is smaller than negative 3.5, all of these x values are smaller than negative 3.5. So whenever x is less than negative 3.5. And the other part, it's increasing. So U for union. And whenever my x values is greater than 0.5, right? Because from here on out, I am increasing also. So x also greater than 0.5. Okay. Where was it decreasing? It was decreasing from here to here. Okay. And so that is between the x values of negative 3.5 and 0.5. Okay. Where is it constant? Not applicable for this graph. It does not flatline. Okay. So let us flip. Okay. Then the next part is asking about relative extrema. So we're talking about our maxes, our mins. Our max is the top of the hill. Our minimum is the bottom of the valley. Okay. So here, I see a top of the hill here. I see a bottom of the valley here. Okay. So this is a max, this is a minimum. Okay, so this maximum, the ordered pair here is negative 2, 4.5. Okay. This minimum, this bottom of the valley here is at 3, negative 8. Okay, nice and easy. Okay, so then let's look here. Right, so here I have a top of the hill. This is a max. Here I have a bottom of the valley. This is a min. Right, so max here, min here. Okay, so the max here, it's approximately negative 3.5 and maybe like 21. So negative 3.5, about 21. This minimum, this bottom of the valley, is here at like negative 0.5, 11. 0.5, negative 11. Okay. So now I'm going to have you try this one on your own. Where is the max and the mins? So here we have two relative minimums. This one is at 1, -10. This one is at 6, 10. Okay, and then we have one relative max, one top of the hill here at 4, 40. Okay. The next thing we're going to find is what we call domain and range. And so what I want you to think is domain, think left to right, how far left and right we go. Range deals with whatever y values we have. It is up and down. So domain is x, range is y. Up and down, left and right. Okay, so let's start with domain. Okay. So here I'm going to start from the left, so my smallest number. Okay, so here I'm going to go to the left. All of a sudden, here I hit my graph. This is an arrow. This is telling me that here it's going to keep going to the right forever and ever and ever towards all my negative numbers. Okay. Here, then I keep going, and so I'm still hitting my graph, hitting my graph, hitting my graph. Then here, I hit another arrow. So this arrow means that it's going to keep going on forever and ever towards the right. Because it's going to the left and the right forever for domain, we consider that all real numbers. It's going to touch every single number. Okay. Range, we're going up and down. Okay, so here we're going to start from the bottom of our graph. Okay. And we go, and we go, and we go, and we go. And then the first number I hit is right here. This is the first point I hit from the bottom. Right? So 1, 2, 3, 4. So this is a -4. Right? And then here, and then I go up and up and up and up and up and up. And then these arrows are pointing up, meaning I'm going to go up forever and hit everything. So all of my y values are going to be greater than or equal to -4. So y greater than or equal to -4. Okay. And then one way we write it, this is inequality notation. Okay. Another way you could actually write it is that it's going to go from -4 up towards infinity forever. Okay. This is what we call interval notation. We're not really going to teach it this year, but this is another way to write our range. Instead of inequalities, we can also write it as in intervals. Right? And another way to write all real numbers is we can say that it goes from -infinity to positive infinity. It covers everything. Okay? So let's try it again. So here is domain. Okay? So domain again is my x values. I'm going to start left to right. Okay? So here from my graph, boom, 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 boom. I hit this. This here is a -3. Okay? And then I'm still hitting every single point, every single point, every single point, every single point. And then here I stop, and this x value is 1. So all of my x values are somewhere between -3 and 1. Okay? And you can't quite see it, but this here is an open circle, so I'm going to leave it as this. This here is a closed circle, which means it includes it, so I'm going to put that bar right here. And then speaking of interval notation, another way to write it is that it goes from -3 to 1. Okay? And this bracket is the same as the equal to on the bottom. This parentheses is the same as not having that. It's the same as an open circle and a closed circle. Okay? It looks like it's a point, but it really isn't. It just looks that way, but it's not an ordered pair. Okay? So let's talk about range. Okay, so range is our y values. It's up and down. So I'm going to start from the bottom. Boom, 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 boom. Hit. So this y value is -4. Okay, and then I'm hitting everything. I'm touching everything. I'm touching everything up until here. And this y value here is 0. Okay, so it touches the -4, so it includes it. So down here, equal to, and then 0 here, it touches it here. Even though this is an open circle and doesn't include it, this one does, so I include it here. And then another way to write it, interval notation, is it goes from -4 to 0. You just need to write it in inequality notation, but I also wanted to show you this interval notation, which you will see again in further math classes. Okay. So again, remember, domain is our x values. It goes how far left and right it goes. Range is our y values. It's up and down. Okay? So why don't you try this one on your own? Give me the domain and give me the range. Okay, this is what you should have gotten. Domain, it goes from -5 right here, right? I'm going left to right, so it starts here at -5. That's the x value. And then continues all the way until here. This x value here is 6. Okay, so that means all of these x values are between -5 and 6. It includes the -5 here because of the closed circle, but it doesn't include the 6 here because it's an open circle. Okay, range is up and down. So here it hits it at -7. Even though it doesn't include this -7, it does include it here. So that's why I still have the equal to on the bottom. And then I touch every y value up until this point here, which is 0. Okay, and it includes that point, so that's why it's an equal to. Okay, so let's try another one here. So domain and range. Okay, so domain here hits my graph. I hit that arrow, which means it's technically going to the left forever. Okay, and then I'm touching everything, and touching everything. And then I hit an arrow again here on the right, which means it's going to go to the right forever as well. So since it's going to the left and right and it touches every single number, this is all real numbers, right? And another way to think about it, if we talk about interval notation again, it goes from everything from -infinity to infinity, right? Kind of like this one goes from everything from -5 to 6, or this one goes from everything between -7 and 0. Okay, but again, you just need to write it in inequality notation. But if you want to be a little bit more advanced and you want to try writing it in interval notation, you can do that too. Okay, so the next thing is range. Okay, so up and down. So here I'm going to go from the bottom first. I hit that arrow, so it means everything below this as well, all the way up to here where it hits it at 0. Okay, so it's 0 and everything less than that. So here, my y values is everything that is less than 0. Okay. Then I hit nothing from here, from 0 to 1. But then once I hit 1 again, I'm hitting everything again. Right? So a union, another part of this range, is everything from 1 and higher. So everything that is greater than 1 as well. And since it includes this one, I'm going to put an equal to as well. Okay? So if I were to do this in interval notation, everything that is less than 0, that is everything from -infinity to 0. And everything from 1 to infinity. From 1 to infinity. Okay. Let's turn. Okay. So then, next part here, okay, domain and range. Okay, so here, domain going left to right, boom, I hit that arrow, so that includes everything smaller than this, all the way up to here, which is at 0. Okay, but then I can see that on the top part of the graph, I'm including it again until I hit another arrow on the right side. So since I have this arrow on the left all the way to here, 0, but then I pick it up here and then all the way arrow to the right, this means my domain is all real numbers. Okay? Or in other words, I'm going from everything from -infinity to infinity, right? Because this is towards -infinity. This side where the arrow is pointing towards infinity. Okay, range here, so starting from the bottom now, I hit this, and this y value here is -2. So here, my y value equals -2. Okay, then afterwards, I'm not hitting anything until here again, and this y value is 1, 2, 3, 4, 5, all the way to up to positive infinity. Right? So here, I also have everything that is bigger than 5. Right? So interval notation, it would be -2 by itself, and everything from 5 to infinity forever. Okay? Right? But again, you can just give me this. You don't have to write it in interval notation. Okay? So next part here, domain and range. Okay? So here, domain is left to right. So boom, 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 boom. I hit it here. There's a dot here. It is a closed circle. So -5 is where it starts. And then I'm hitting everything, 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 everything up until here at 1. So everything, all of these x values, is somewhere between -5 and 1. Okay, it includes it, so I'm going to put a equal to on the bottom. Then I hit nothing between 1 to 2, right? This is all empty here. Okay, then I start up back at 2 all the way here until this x value of 5. So union everything between 2 and 5. And then because the 5 is a closed circle, I have the equal to. 2 is the open circle, so that's why there is no equal to. Okay? If you were to write this in interval notation, it is everything from -5 to 1 and everything from 2 to 5. Okay? Again, this is not an ordered pair. Okay? Range, going bottom up. So here I hit at -2, so that's my lowest. And then I'm hitting everything, everything. And even though on this side I stop here, but on this part of the graph I'm continuing all the way up until here. So that is everything up till 4. Okay, and since it touches 4 here, it's included. Okay? In interval notation, that would be everything from -2 to 4. Okay? So that was a lot. I'm going to have you try this one on your own. So find all of the features here and then come check your answer. Okay, so this is what you should have gotten. X-intercept, this is the x-axis. It touches it here at -7, 20. Sorry about that. And 40. Y-intercept, here's the y-axis. It crosses it here at 0, 3. Increasing, decreasing constant, remember we're going left to right. So here to here, I am decreasing for everything less than -5 on this left side, right? Then after that words, I'm increasing. Again, I'm just looking at those x values, right? So here from -5 to 2, I'm now moving upwards. Okay, so that's why increasing is between -5 to 2. Okay, then with my finger, I'm going down again, and all of these x values are bigger than 2, right? 2, 4. This one's 4, 10, 4, 0, right? This would be like 6, whatever, right? So that is why x greater than 2. There is no constant. There's no part where it just flat lines like that, so there's no constant not applicable. Relative maximum is the top of the hill, so that's here at 2, 4. And relative minimum is the bottom of the valley. That's here at -5, -3. Then domain. Remember, domain is left and right. It's talking about all my possible x values for my graph. And the range here is up and down. Right? So here, I hit this arrow, meaning it's going to go to the left forever towards -infinity. Right? And then I touch every single point in between, all the way until here I touch another arrow. This is going to the right forever towards positive infinity. Since it's going in both directions forever, that is all real numbers. Okay. Then for range, that's up and down. So I start at the bottom. Boom, I hit this arrow, which means it's going to go down towards -infinity forever. Then I'm touching everything in between, everything in between, everything in between until I hit this. And this is pointing upwards towards positive infinity. So everything from -infinity to positive infinity, that is all real numbers. That's it for today. Thank you for hanging in there. Have a great rest of the day. Bye, guys.